Hi, a very good afternoon we bid to everyone. I'm Eden, together with my group members Noor Izazi, Muhammad Amir Hamza, Shamira, and also Aliyah. We are from Group 3, and today we are going to present tutorial questions for Chapter 7.
Hello everyone, Assalamu alaikum and good day to all. I am Muhammad Amir Hamza Khan Polo. Now I am going to present my part, that is question number 1 A, B, C. Now I am going with my first question, that is question number A. And so the question is, what is the standard error of the mean in this experiment? And the answer is here mu equal to 3.0 and sigma equal to 0.18 and population mean n equal to 440. So the standard error mean is going to be sigma x bar equal to sigma by root n equal to 0.18 by root 40 equal to 0.0285. Now moving to my second slide. So the question B is, what is the probability that the sample mean is between $2.98 and $3.02? And the equation is going to be P bracket 2.98 smaller than X bar smaller than 3.02. And after doing the standardization, we find that P bracket minus 0.7018 smaller than Z smaller than 0.7018. And after putting the value of Z in above the last line, we can find that 0.5 minus 0.2420 plus 0.5 minus 0.2420. We will find the 0.516. And now moving to my third slide, and that is question number C. So the question on C is, what is the probability that the difference between the sample mean and the population mean is less than 0.01? And the answer is going to be at first the equation P bracket x bar minus mu brackets n smaller than 0.01. After doing standardization, we can find that Z is smaller than 0.01 divided by 0.18 by root 40, and P bracket Z is smaller than 0.35. And after reversing, we find that P bracket Z greater than 0.35. Now after now subtracting from the universal value of n in a sample mean, that is 1 minus 0.3632, we find the value of Z from the table equal to 0.6368, and that is the answer for question on C. Now I'm passing it to my next presenter.
So hi everyone, I'm Eden and I will continue question 1D. So the question is, what is the likelihood the sample mean is greater than 3.08? And we can get P in bracket x bar larger than 3.08, and we start the 3.08 inside the formula where we can get 3.08 minus mean, which is 3.00, over standard deviation, which is 0.18, over square root n, where n is sample size, which is 40, and we can get P in bracket Z larger than 0.08 over 0.285, and we can get P in bracket Z larger than 2.81. After that, we can draw a normal graph and show the 2.81, and we can find from the appendix table 2.81, and the final answer will be 0.00248. That's all for question 1D. I will pass my stage to my mate.
So for question 2, the Quality Control Department employs 5 technicians during the day shift. Listed below is the number of times each technician instructed the production foreman to shut down the manufacturing process last week. So for question 2A, how many different samples of 2 technicians are possible from this population? So there are 5 technicians in the table, as you can see. To calculate how many different pair of technicians we can get, we can use a combination formula. You need to grab your calculator and key in the formula. I've put the combination formula in the slide. So there are two ways. The first one is 5 combination 2, or you can use the second method, which you will get the same final answer. That is, you will get 10 different samples of 2 technicians from this population. So question 2b, list all possible samples of 2 observations each and compute the mean of each sample. So from the previous table in the question 2a, you need to list down all the possible samples of 2 different technicians in the table. And we will get Taylor with Hurley, Taylor Gupta, Taylor with Roger, Taylor with Huang, and so on. And to compute the mean of each sample, first you need to sum up the number of shutdowns, which you can get from the previous table too. And then after you sum up, you have to divide the answer with 2, because there are only 2 technicians in each sample. Then you will get the mean of each sample. So for question 2c, compare the mean of the sample mean with the population mean. So I have put the sample mean and the population mean in the formula. For sample mean, you need to sum up all of the sample means that we have calculated in the previous question and divide by 10, because there are 10 different samples in the table. And then the final answer is 3.4 for sample mean. Next, you need to calculate the population mean. You need to sum up all of the number of shutdowns of each technician and divide it by 5, because there are 5 technicians in the table, right? Then you will get 3.4 for the population mean. So to compare or to conclude, the sample mean and the population mean are equal.
Moving on to question 3. Information from the American Institute of Insurance indicates the mean amount of life insurance per household in the United States is $110,000. This distribution follows the normal distribution with a standard deviation of $40,000. So we found from the question that the mean is $110,000 and the standard deviation is $40,000. Question 3a. If we select a random sample of 50 households, what is the standard error of the mean? So the n is 50 and the standard deviation is 40,000. By using the standard error formula, which is sigma over square root n, we calculate using calculator and then we get the answer, which is 5,656.85. 3b. What is the expected shape of the distribution of the sample mean? According to the central limit theorem, as the distribution follows the normal distribution, we may conclude that it is a bell-shaped normal curve. Question 3c. What is the likelihood of selecting a sample with a mean of at least $112,000? We can begin writing the answer. P bracket x is greater equal to 112,000 by using Z formula, which is sample mean minus mean over standard deviation over square root of sample size. And we can substitute all the value from the question into the formula, which is 112,000 sample mean minus 110,000 mean over 40,000 standard deviation over square root 50 sample size. We can calculate the answer using calculator and then we get P bracket Z is greater equal to 0.35. And then we can use appendix table to find the final answer, which is 0.3632. By using the value of 0.3632 and 0.35, we can now draw the graph.
So let's move on to question 3D. The question is, what is the likelihood of selecting a sample with a mean of more than 100,000? So we can get P in bracket x bar larger than 100,000. So we sub the 100,000 inside the formula, where in P in bracket Z larger than 100,000 minus mean, which is 110,000, over standard deviation, which is 40,000, over square root n, where n is sample size, which is 50. So we can get P in bracket Z larger than negative 1.77. So we can get what 1 minus p in bracket z larger than 1.77, and if we refer to the appendix table, we can get 1 minus 0.0384, and the final answer for question 3D is 0.9616. So I will pass my time to my mate.
Hi, my name is Shamira Atratusna, and now I will be explaining about question number 3E, which is the question: find the likelihood of selecting a sample with mean of more than $100,000 but less than $112,000. For this question, first of all, you have to list out the keyword first to make it more easier, which is the questions 1, a sample with mean of more than $100,000 but less than $112,000. So it will be P in bracket 100,000 less than X bar less than 112,000. So we still use the Z formula, which is the sampling distribution of sample mean. We have to substitute all the formula for all the value into the formula, and we will get P in bracket negative 1.77 less than Z less than 0.35. We must remember that to use normal distribution table, we have to make all the value become positive and it must be greater than. So it will be 1 minus P in bracket Z greater than 1.77 minus P in bracket Z greater than 0.35. If we refer to the appendix table, we will see that the value of 1.77 will be 0.0384, and for 0.35 it will be 0.3632, and after we minus all, which is 1 minus 0.0384 minus 0.3632, the final answer will be 0.5984. Question number 4. The mean SAT score for Division 1 student athlete is 947 with a standard deviation of 205. If you select random sample of 60 of this student, what is the probability the mean is below 900? As I said before, we have to list out all the keyword first. So as stated in the questions, the means given is 947, standard deviation is 205, sample size is 60, and the questions 1 P in bracket X bar less than 900. So we still use that formula, which is sampling distributions of sample mean, and we have to substitute all the information given into that formula, which is P in bracket Z less than 900 sample mean minus 947 mean over 205 standard deviation over square root of 60, which is the sample size, and we will get P in bracket Z less than negative 1.78. And as I mentioned before, if we want to use the normal distribution table, all the value must be positive and greater than. So we have to change the symbol of inequalities to be greater than. So it will be P in bracket Z greater than 1.78. So if we refer to the appendix, the value of Z of 1.78 will be 0.0375, and the final answer will be 0.0375. Thank you.
That's all for our presentation today. Thank you and have a nice day.